We really need help on the calibration process because we tried more than 100 times and always give us finicky results. Right now I'm going to explain the process that we understood from the GitHub repository. We tried many different approaches, but this one that we're going to show is the one that we think it's the most appropriate. We tried many different cameras, many different filters. We tried basically everything. Right now we have here a setup with 4 cameras. They are set up at 2.5 meters high, 3 meters apart of each other, and exactly in the middle we have an origin point. Everything is connected to that laptop. The laptop is connected to an ESP32 and to the 4 cameras through a powered USB hub here in the back. We did the process of calibration the cameras with that we showed already using the grid, and right now we are going to show the process of calibration. Basically what we do is we use the magic wand that is basically a stick with an infrared LED on the tip and we have this AA battery connected to a button that just flick the LED, and we catch some samples. We start camera pose calibration. We catch some samples. We tried many different approaches from 2,000 points to 20 points. We find out that our better shots were with around 200 and 600 points. Because as soon as you start the light, like the LED, the system captures the points automatically and save them. So if you keep the light on, it will just keep capturing points. So we just flick around until we got around 200 or 300 points, and we use it to do the first calculation. That is the camera pose. Then the second step, we start live triangulation again, and we set 2 LEDs apart. On the system, it's 15 centimeters apart. This is exactly what we have in the drone. And when we place the battery and hide one of the LEDs, is exactly what we have. 2 LEDs 15 centimeters apart of each other. We place it on the middle, sometimes higher. We have better results in a chair or bench. And then with that data, sometimes we go around with it, and then with that data we run scale. So the system uses this distance between the LEDs to scale up the 3D space that we are going to use. The third step is acquire floor. That is the one that seems to be the one that is tricky. What we do is we use the wand again to paint the floor basically with a lot of points. And these points generate something roughly flat on the front end, and then we click on the acquire floor and everything flips. The first camera goes to the origin and the entire world is flipped there. And as last point, we just capture one point in the center as the origin point, and then we set the origin, and sometimes we have something resembling what we have here, and then we can see on the 3JS on the front end that the points are roughly corresponding to the setup that we have. But in general, the object location is not steady enough. It comes and goes and crashes. We are able to sometimes arm the drone, but it never flies in a pattern that is reliable enough. So right now it comes the question, like even trying all these different approaches, we ask for Joshua and the community around it, what can we do to try to make it more stable?
Yeah, also how to do the calibration to get the how can we know if our intrinsic values of the camera matrix are correct?
We really want to make it like a milestone for other people to work on it. We want to make better documentation once it's working, but we are really now at a point that we need help. This is what we are asking here.